Find the condition on m, given that y equals mx is tangential to this circle. I've labelled them as 1 and 2, so let's find out where they intersect then by sub in 1 into 2. And this will give us the x values where they intersect. We know that these x values, for them to be tangential, must coincide. So the quadratic needs to only have one real root. So let's do the substitution first then. So x squared plus y squared, which is mx. So mx as an object squared is mx times mx. So that's m squared x squared, isn't it? Plus 6x plus 4y, which is 4 lots of mx, plus 9 equals 0. So that tells us now then x squared, so we got m squared plus 1, lots of x squared, so that's those two terms done. 4m plus 6, and that's lots of x, plus 9 equals 0. So here this quadratic will have only one solution. So in other words, b squared minus 4ac equals 0 gives, that condition gives then, for one root, b squared 4m plus 6 squared minus 4 times a, m squared plus 1 in a bracket, more than one term, times c, 9, equals 0. So we get, expand this bracket, 4 4s are 16, so that's 16m squared. 4 6s are 24, double that is 48, so it's 48 lots of m. 6 squared is 36, minus, then we've got 4m squared, times 9, so that's 36. So it's minus 36m squared. And then we've got 36 with a minus again times 1 is minus 36 equals 0. So what have we got then? We've got 16 minus 36m squared, which is minus 20m squared. Then we've got 48m, just plus 48m then. And then we've got 36, take 36. 36 take 36 cancels. That equals 0 then. So we can solve that easily. Here's the condition on m then, first of all. So that's that done. But let's just, why not, while we're at it, just get m, because it's easy to do. So here we could take an m outside a bracket and a 4. So let's take a minus 4m outside. Inside we'd have 5m. That would give us our minus 20m squared. And here we'd need a minus 12. 4m times 12 minus times minus is plus 48m. And that tells us then that m equals 0, or m is equal to 12 over 5, isn't it? So let's do a quick check with the plotter then, just to check that our condition, which is the answer for the problem, is correct by verifying it by inspection with these two gradients. Here's the plot then. I've entered them already, so let's just tap it out. I'll bring the screen down a bit so we can see what we're doing. So here's the functions. I've entered them as I say. So we'll enter that then, submit this as a plot, check we've got the inputs correctly written, and you can see here, here's the circle, and here's the two lines, the gradients that we mentioned that are tangential.